Let's take a closer look at what happens when we pass arguments to functions. So you've seen this example before. This example was about showing that variables inside a function are scoped to within inside the function. So I've got a variable k. Inside the function, I happen to have a parameter also called k. And what I do to the k inside the function really doesn't affect the value of k outside the function because they're not the same k, right? This one is scoped to the function. And if I run this code, you can see that when we're done, the original k is unchanged. Let's look at a different example. So here I have an example that's structurally identical. I'm setting a variable I to an array, 1, 2, 3, 4, 5. Inside the array, I'm going to reverse it. I'm calling the reverse method on the array object. You can look that up in the documentation. And basically, the output of that, if it works, should be 5, 4, 3, 2, 1. And then when we exit the function, I'm going to show the original value, the value of the original I, so we can see scope at work. And when I run this, we can see 1, 2, 3, 4, 5, which is what we expect, and then 5, 4, 3, 2, 1, which is what we expect. But when we're done, outside of the function, I is 5, 4, 3, 2, 1. Now this is totally different than what we see in this example, where outside of the function k is unchanged. Now this is not an exception to the rule about variables being scoped to within a function. The same scope rule is actually being applied here, and what's happening is something different. And this is the concept of passing by reference versus passing by value. And this is a feature of many programming languages, and in many programming languages you have explicit control. If you're programming in C, you have explicit control whether you're passing by reference or by value. In JavaScript, there's an implicit rule that you need to understand when you're writing code so that you know what's going to happen. And let's take a look at what's really going on here. So primitive data types, and when I say primitive data types, I mean things that are just like a number, a string, a Boolean in JavaScript, are passed by value. Here I have the variable a, I've set it to 4, and if I pass a into a function, what I'm really passing is the 4. I'm passing the contents of a. This container called a has a 4 in it, and I'm sending a 4. In a way, it's a copy of a 4, making a new 4 and sending it into the function. And then whatever I do to the 4 inside the function doesn't affect a, because I've simply copied the value of a in the function call. If, on the other hand, I'm not dealing with a primitive data type, if I have an array object, an HTML object from a web page, we do document get element by ID, and we get back an object that's an HTML element, the window object, there's all kinds of objects in JavaScript. If I'm passing an object to a function, what I'm passing is a reference. More specifically, this container called a doesn't actually contain the array itself. It contains a reference that points to where that array sits in memory. And so if I pass a to a function, what I'm doing is I'm taking the reference and I'm sending it to the function, and it points back to the original array. So in this case, if I modify a inside my function, I'm actually modifying the original array. If I do an operation that changes the array, that change is going to be reflected in the original object. And when you think about it, this kind of makes sense. If we got an HTML element from a page and passed it to a function that was going to change its background color using the style property, it wouldn't help me if I had copied that entire object and it wasn't the one that sits in the page. I'm passing a reference to the original HTML element, which is part of the DOM and it sits in the page, and that's why I can change it. Now, this doesn't mean that I can do anything I want to a and it's going to be reflected in the original. Consider this example. So I'm passing my pointer, my reference to the array 4, 5, 6 into this function. Now if I reassign a, let's say to a new array called 6, 7, 8, I've overwritten the value of a. It no longer points to this function. And of course now if I do reverse on a, I'm going to get 8, 7, 6. And this one continues to be unchanged. So if I'm running some sort of a method that actually changes the array, those changes will be reflected outside of the function. If I reassign A to point to something else, then that's basically the same case as this, or it's the same case as this, where I've reassigned K to some new value and it doesn't matter what it used to point to because I've overwritten it. So pass by value and pass by reference is an important concept, and you'll have to be cognizant of it as we go through the course. When you're writing your code, you may find yourself in a circumstance where it's not doing what you expected, and it will be because you were thinking you were passing a reference, but you're passing a value, or vice versa. And the basic rule is, if it's an object, you are passing a reference, and if it's a primitive data type, you are passing a copy.